Okay, the summary of the content, we'll go through the introduction, and then we will look at all the policies that we have in Malaysia. We have so many policies regarding the energy, okay, and also the ACTA lah, the Act, okay, power plant project planning, and then some generation cost analysis, power plant project risk, and also the summary. So generally this topic ni mainly we cover apa tu? Some sense of project management lah. Okay. For today I'll try to cover up to the power plant project planning. Just a bit of introduction. Okay, we know that power plant is very important to the nation. It provides the power which is absolutely needed in any countries in the world. So that's why this has been gazetted as one of the important strategic target for any safety and security of any countries in the world. So we know that power plant, it require huge investment, and it takes time to get to the return of investment. Okay, for example, if you look at Manjung 123 unit last time, the cost to construct all the 3 units altogether is around 6 to 7 billion. So that is the kind of investment that we need to put in order to generate the electricity. So the planner, we have the economic planner for the country. They always look at the needs to build a new power plant. Okay, so there are many characteristics or many factors that is needed, okay, to build the power plant. So this is, part of it we will try to look in general lah. Very simple, but kind of common sense for us to look at what are the factors that we need to see before we decide to build a power plant. Okay, it involves forecasting of certain economics or technical parameters. It involves uncertainty. It involves many risks lah. So that's why in the project management for the construction of the new power plant, we always look at the risk management issue as well. So proper planning is needed, okay, to ensure adequate, secure, and also cost-effective supply of electricity. Okay, in addition to that, we also try to make use of the efficient utilization of all the power plants, the current power plant that we have, okay, before we decide to construct a new one. Okay, and then we have to look at the environmental consideration as well, and also the sustainable issue pertaining to the new power plant that you plan to build. Okay. Currently, I think for the government policy, there is no more thermal plants to be built because we are focusing on the construction of the new solar and the renewable energy source. But that also depends on how fast we require the electricity in the future. We still need to look at the demand side of it lah. Okay, in terms of the policy, okay, this is very much related to the power generation. We have national energy policy. Okay, this is not restricted to the power generation. Okay, anything that relates to the energy are governed by this national energy policy. Okay, the energy policy cover the supply objective. Okay, the supply of energy objective to ensure adequate, secure, and cost-effective supply. And then the utilization. So first you have the supply, and then second you have the utilization. Usually utilization is fairly straightforward lah. We want the energy used to be as efficient as possible. We don't want to waste energy. Okay, that is the simple word to describe what is the utilization objective of this energy. Then we have the environmental. Okay, objective. This is also fairly straightforward. We don't have to crack your head to think about the environmental things, as long as we try to avoid or we try to minimize the negative impact to the environment, that is considered achieved. Okay, and then we have fuel diversification policy, which is introduced long ago, 1981. I think the first major oil crisis, whereby before 1981, if you know, we depend very much on the oil. Okay, we depend very much on the oil. So I think around that year, when oil is depleted, the oil price become very expensive at that time. So we try to look for another method of producing the power. So this is where we include coal as part of our energy mix in the country. Okay, so energy, the fuel diversification also needs to be reviewed, and maybe every, I don't know, 3 years, 5 years. It depends on the world current situation, on what is the cheapest, okay, available fossil fuel for the generation of this electricity. So that's why it is important to be reviewed periodically. Okay, and then if you look at the 8th Malaysian Plan in 2001 2005, this is where Malaysia start to venture into renewable energy. So in this case, they include renewable energy as part of the fuel diversification. So in addition to the existing gas, hydro and whatnot, in 2001 to 2005, we introduced the renewable energy. So let's have a look here at the National Renewable Energy Policy and Action Plan. This is based on 2009. Okay, even though you say, let's say, if for the government, if they say that, okay, I want to introduce this renewable energy to the country, okay, we cannot simply say that because if you want to start something, it's gonna be very difficult for the company or for the players, for the power generation player to embrace the renewable energy. So usually what we do is that if you want to introduce something in the country, so you have to come up with the action plan, or in other words, you have to come up with the act. Okay, by using the act, then we can enforce, or we can force all these companies to start venture into the renewable energy. Otherwise, it won't work. Okay, otherwise there's no incentive and whatnot, and people don't bother to venture in this new energy policy. So that's why in all policy that the government make, they have to come up with the akta, ataupun act, and also the action plan. So in this case, for the renewable energy, usually we have the policy statement lah. Okay, you want to enhance the utilization of RE, okay, to contribute towards the national electricity supply security, sustainable, and also socio-economic development. And then we have a few objectives lah under the renewable energy. Maybe you can just read through later on. We have the National Green Technology Policy 2009. So this is also in line. This is where we start to rigorously looking at the renewable energy or green technology. Okay, so this is where it starts lah back in 2009. Okay, in 2015 we have another act or action plan. We have National Energy Efficiency Action Plan. This has nothing to do with the fuel. This has nothing to do with the renewable energy and whatnot. So this energy efficiency, they only focus on how best we can utilize the energy. In other words, you try to make sure that all the utilization of energy is super efficient. Okay, promote energy efficiency measure in contributing to the sustainable economic development. So we don't want any waste because before this National Energy Efficiency Action Plan takes place, most of the factories, most of the big company, they are not utilizing the energy efficiently. There are a lot of waste. So that's why we introduce this, so that we can at least try to make use of the existing energy available rather than building a new power plant. So why not we just make use of the efficient utilization of energy. So this is generally the objective lah of the National Energy Efficiency Action Plan. Okay, this is the main topics that I want to discuss today in terms of the power plant project planning. So this is more like part of the project management principle. but we adopt the project management to the power generation industry or power generation business. So before we decide to build a power plant, what are the factors, okay, to be considered in the power plant project planning? There are many things that we need to look into. Okay, for example, here we have to look at the current power demand, not only current, but maybe you have to predict the future power demand of the country. Then we have to look at the existing capacity factor of the total power plant that we have in Malaysia. So we need to look at the capacity factor. Usually the capacity factor will tells us whether the plant is already old, needs to be replaced or not. Okay, for example, if the capacity factor is low, you know that there are many plants that needs replacement. So by looking at this capacity factor, we can do or we can make a decision whether to build or not to build the power plant. Then we have system stability. This one is related to the grid. Okay, we need to look at the location. Okay, location of the power plant. Is there a still available location that is suitable to build a new power plant? So it also depends on the type of plant as well. The generation mix, okay, whether the current generation mix is still applicable to for the next 5 years, as an example. Okay, now we know that the oil price is getting very much cheap. Okay, but we don't know whether it's gonna be cheap like this for the next few years, which I think not ni lah. Okay, and then we need to look at the support available for that particular location. Where do you get your financing or your loan? Okay, we need to look at the existing infrastructure that is available, environmental issue, and also we need to look at our system reserve lah, whether we still have plenty of reserve or our reserve is already shrinking that needs to add or to top up. So this is also some consideration that we need to look into for construction of the new power plant. Okay, let's have a look at one of these factors one by one. The first one is the power demand forecast. So before you can build your power plant, you need to look at your demand forecast. Okay, the demand of electricity. If there is no demand, there is no point for us to build a new power plant. So demand is referred to the total power and energy demand. Okay, we can also look at the peak power demand. Okay, you know that peak power demand they occur only for a few hours in a day, kan? But then it is still important for the power generators to fulfill this peak power demand, because if we fail to fulfill the peak power demand, then it might affect the total system stability of the country. So we need to look at the some kind of projection lah, or the graph as in this example. Okay, this is the old one that we use. Okay, from 2000 to 2003. So these are the kind of projection, and you have to better predict your requirement lah for the energy. Okay, other forecast that is needed also, we need to look at our GDP, we need to look at our economic growth and also population. Because if you can still remember, these factors are also influencing the utilization of electricity. The higher the GDP, the higher the economic growth and population, the more power is required, okay, to meet all these demand. So that's why the power demand is an important factor we need to consider before we can build a new power plant. Then we have to look at the generation mix. This is related to the type of fuel that we are currently using. Okay, whether our power generation is done through hydro, through natural gas, combined cycle or single cycle, whether we are depending very much on the coal and also the renewable energy. And the power generation mix is also influenced by the government policy. Okay, it is the government who decide on what are the fuel that we want to use, okay, to produce our electricity for the next 5 or 10 years. Okay, question of fuel reserve, sustainability and security of supply. Okay, we need to look at the world fuel reserve as well. I mean, whether, let's say, for example, we are talking about coal, you need to know how long will the coal still be available for our utilization. Okay, similarly to other types of fuel as well. Okay, we know that we are now embarking on the renewable energy. So that is also part of the government's policy. And of course, for the generation mix, they always refer to the fuel price and also its trend. Okay, if the fuel price is predicted to increase significantly, then we might want to consider using different fuel. Okay, the third factor is related to the system reserve. Okay, for the system reserve ni, we observe our national reserve as I highlighted before. For Malaysia, we fix our system reserve to be around 30%. But in what other countries has practiced is different lah. Okay, it depends, but these are some of the method used to determine how much reserve that you want to put for your country. Okay, system reserve, it means the extra capacity needed for security of supply. So in order to determine the system reserve, these are the three methods used. Okay, the first one is you look at your output of the largest unit or largest power plant. In Malaysia case, currently one unit maximum that we have is 1000 megawatt. So that is the output of the largest unit in a country, in our country, plus the output of the next largest unit. We have a few unit that can produce 1000 megawatt. So in this case, if we are using this method, okay, then our system reserve is around 2000 megawatt, 1000 plus 1000. So that would be our estimation for our system reserve. And then the next method is by using this equation. We look at our largest unit in the country plus 10% of the peak load. So let's say if the peaking load is around 30,000 lah. If the peaking load is 30,000, then 10% of that 30,000 is around 3,000 megawatt. So you just need to add 1,000 plus the 3,000. So you got your 4,000 megawatt as your reserve. Okay, so that could be one of the method that we can use to determine our system reserve. The last one is the simplest one lah. Okay, the last one is by taking 15% to 30% of the total peaking load. So if the total maximum peaking load is around 30,000 megawatt for Malaysia, then we just need to say either you want to put in 15% or 30% from the total 30,000 megawatt. So that is what we are currently practicing. We put around 30,000, 30% from the total peaking load to be our system reserve. Okay, the method that is suitable, it depends. There is no right or wrong. It depends on whether how efficient your plant is, or it depends on how reliable your plant is. Maybe if you think that your plant is reliable, you can just put in the first one. So you just take the risk. Okay, just to say that I want my system reserve to be only 2,000 megawatt from the total generation of 30,000 megawatt as an example. Okay, if you look at the system reserve ni, system reserve, I mean the key mechanism of how system reserve work is that at one particular time, let's say for Malaysia, you are talking about around 30,000 megawatt peaking load at one time. So usually we need to supply that 30,000 megawatt. And if you know that this 30,000 megawatt is contributed by many units in the country or many power plant in the country, if one unit maximum is 1,000 megawatt, let's say one unit suddenly shut down, so instead of having 30,000 megawatt, you are having around 29,000 megawatt because 1,000 megawatt is not able to be produced. So the question is whether at that particular shutdown or at that particular problem that happened, whether the demand is still 30,000 or less than that. So that's why the largest unit is very, very important. And that's why also we don't want our unit to be that high lah. I mean, maybe it is possible to have a unit that can produce 5,000 megawatt. Okay, 5,000 megawatt for one unit. You imagine if that 5,000 megawatt unit is shut down, then it will pull the whole demand, okay, to zero, because you are not able to produce 5,000 megawatt, which is very, very large lah. So that's why we limit our one unit capability to produce maybe up to 1,000 megawatt maximum, just for the security of the country. Okay, and then capacity factor, this is fairly straightforward, is another important factor, okay, for consideration before we can build our power plant. Okay, capacity factor, you need to determine the expected energy to be generated. So usually it depends, I mean, you know that the definition of capacity factor is the power, or is the energy that is actually produced by the power plant divided by the maximum, okay, or the maximum rated power for that particular plant. In ideal case scenario, we expect the capacity factor to be 1. So if the capacity factor is 0, it means that the power plant is not able to operate. So this can also be tied up with the age of the unit lah. If the capacity factor is 50%, as an example, you know that the unit is already old and it might be need to be replaced. So this is how capacity factor affects the decision whether we want to build the power plant or not. Environmental issue, this is also fairly straightforward. It depends on the environmental impact analysis. So if you decide to build a power plant in certain location, in one location that you have selected, before you are allowed to construct the power plant, we have to go through the environmental impact assessment, okay, by a third party to evaluate how this power plant will impact the environment for that particular location. Okay, emission limit, the effluents, the waste disposal method, these are needed to be considered, okay, if you have selected the location to build the power plant. Okay, you have to identify the pollution abatement device. How do we want to eliminate the sulfur dioxide? How do we want to eliminate the nitrous oxide? Okay, how do you want to build your wastewater treatment plants and whatnot? These are also consideration that we have to think about. And then remember, if you want to build the power plant, usually the generators will do some kind of loan, okay, because the price is very, very expensive. We don't have any cash to build the power plant. Okay, and then this financier or this loan giver, they put in quite a strict condition. Among the condition that usually they put in is regarding the environmental issue. Okay, maybe you are borrowing money from the World Bank as an example to build the power plant, and then the World Bank say that if you want to build the plant, you need to make sure this criteria regarding the environmental issue. So it has to satisfy the financial condition relating to the environment. So that is on the environmental. In terms of technical support, okay, this is also very important. We are talking about if you want to operate a power plant, whether you have sufficient human resource, sufficient knowledgeable engineers to operate your power plant, okay, for project management, for finance, for the design, construction, commissioning, operation and maintenance. Okay, this is especially true when you are talking about nuclear power plant. For nuclear power plant, this is even stricter lah. It's even tough in the sense that you have to train your operators to be well expert lah, especially for those working in the nuclear plant. Okay, so you have to show this to your financial or to your policy makers, okay, before they allow us to construct the new power plant. Okay, it influence the level of technology to be adopted. Okay, this is especially true for nuclear lah. Okay, we want to make sure that the safety of the country is in place, so that's why it is important. And also the availability of local vendor. This is usually the government will put in this as part of the requirement before they allow you to start constructing your power plant. We know that for most of the technology available, okay, we import all this technology, we buy from the shelf for all this technology, but in terms of the support, okay, maybe some parts or some component we are able to manufacture or to fabricate it locally. So even though you are appointing overseas company to build your power plant, they have to abide by finding a local partner to outsource some of the fabrication or manufacturing of certain components or part, not the major one, but maybe the minor one that support the operation of the major equipment. Okay, these are the example of the environmental impact assessment that was done during the construction of Janamanjung 1 to 3 unit. So the environmental impact assessment was done by TNRD last time. So what are the kind of impact assessment that they are doing? So usually they will look at the landscape and also visual study. They will look at the climate and also meteorological data, okay, for that particular location. They will look at the flora and fauna, okay, whether the construction will affect the fish, as an example, whether is there any clearance of forests required for the construction of the power plant. So these are the kind of things. Okay, they look at the baseline data for the water, seawater quality, ambient air quality. They look at the possible noise induced from the plant when it is constructed. Okay, if there are any issue, what are the mitigation plan, okay, given by the operators or the power generation company? Okay, and then of course they need to look at the environmental management plan. Okay, for example, the construction you want to transfer or you want to transport the major equipment from Port Klang, as an example, to the location, whether you have done the due diligence in terms of the road, okay, that leads to your plant, because it will affect the people living in that areas, and also all the operational issues lah. So these are the kind of environmental impact assessment that needs to be done, okay, before government allow for the construction of the new plant. Okay, system stability, we also need to look at this system stability. This is also related to the total maximum megawatt of a particular unit. It is said here that the new power plant or the new unit should not be too large, as it may disrupt the overall system stability. Okay, this is given by this diagram. Let's say, for example, for any country, the average megawatt for different units are 120, 120, 300, 300, 120, 120, 110, and suddenly you want to build a 700. So this will definitely affect the total system stability. Why do I say that it will affect? If let's say all of these plant or all of these units are operating at normally, and then suddenly the 700 megawatt is forced to shut down. Okay, of course, because the amount is high, considered high as compared to the rest, it can cover maybe 2 or 3 plants at one go. So that's why if this is down, the rest of the grid will be collapsed lah. So usually this is called the system stability. Okay, the size of the largest unit must not exceed the system reserve capacity. So it is not possible if you have the largest unit of 1,000.
you allow your system reserve to be at 1,000 as well, because if that 1,000 unit down, you don't have any more reserve, zero reserve. So that is dangerous lah, okay, in terms of the security. Then we have the source of financing. Okay, there are different types of financing available for the power plant construction, or maybe for any other projects as well. It is more or less similar. It is either based on the equity base, or either it is based on the debt base. Source of financing, whether you are looking for the financial from domestic or from foreign. Okay, maybe from banks, multilateral institution. You have many institution combining to give you the loan. Okay, maybe you get your finance directly from the supplier. As an example, the supplier of the steam turbine, they just give you the loan, okay, to buy their steam turbine. So this is also possible. Okay, the capital market, the institutional equity, and also some kind of sponsor equity. Okay, so you have different options in this case. So as a planner, you need to look at what are, I mean, which one is the most viable lah for a particular power generation company. The next factor that we need to look is infrastructure. Okay, infrastructure, it refer to the available infra on the site lah. Either at the site you already have road, water pipeline, okay, telephone line, whether you have already have a railway. If you need to transfer your coal using the railway, then you have to make sure that the railway line is already there. Either it is close to the port. This is also important, yeah. Okay, because of the transfer of all the major equipment, usually the shipment comes from the ship. Of course, they will dock at the port. Pelabuhan Kelang, as an example, from Pelabuhan Kelang to Manjung. So how long is the distance? So these are the logistic that you need to consider lah. Okay, requirement to add or upgrade the infrastructure. Not only that you are looking at the current scenario, you might as well want to project what happen in 10 years time, whether is there any space, okay, for the expansion of your power plant. Okay, is there any space for the construction of a new road? So these are the kind of things that we need to look into, okay, with regards to the infrastructure. Okay, location is always a controversy, okay, because you know that when we want to build the power plant, it is kind of, I mean, it gives some kind of negative impacts to the society. Okay, people always think about pollution and something that is negative lah related to the new power plant. So to select the location, there are a lot of consideration that to be done. Okay, either political or apolitical. You have to make sure that you have to have a site preparation, infrastructure, land acquisition. In this case, we always work closely with the state government. Okay, so this is the most important thing lah. You have to make sure that you got permission from the state, and usually the state will also request for some kind of agreement lah. Okay, what they will get out of that particular project in addition to the electricity. Okay, land acquisition. If there is no land, you might want to do land reclamation. Okay, you tambak. Manjung is one of the example of the land reclamation based project. Okay, the load dispatch area and also the environment. Okay, requirement for plant auxiliaries as well. Maybe in your site too, you have to have maybe supporting plant. Okay, water treatment plant as an example. So those are the plant auxiliaries that we need to take into account. The cooling water, okay, you might want to use your cooling water directly from the sea, or you have to construct the new cooling tower for the cooling water system. Then you need to look at the transmission line, whether is there any existing transmission line or you have to construct the new transmission line. So these are another consideration, because transmission line, it can cost you a lot of money as well to build a new one. Okay, jetty, switch yards, and also quarters for the operators. Okay, I think those are 10 of the important factor that needs to be considered in any power plant project planning. We will stop here, and then maybe next week we'll continue for the power plant economics in terms of determining the price of electricity for a given fuel or for a given site. Okay, I think that's all for me. Have you got any questions? Something